Okay, your tens. So, an introduction to exponents. If you have forgotten all of this from last year, don't worry about it. I'm going to start from scratch. Today's lesson is supposed to be pretty much revision. So, exponents look very easy. You're going to like the homework. It goes very fast. But unfortunately, they are not that easy because people see things that are not there. So, for example, if you have 5 to the 3, if you are seeing threes, we're going to have a very big problem because that is just 3 5s. So this is an instruction. It is not a number 3. And if you see threes, we're going to have a problem. So as we go up doing exponents, they become more and more algebraic. So you don't need to use the rules for a lot of the ones you're going to use this year, but in the future you're going to have to use the rules a lot. So it's very, very important you get used to them. And definitely this year you're going to use the rules some of the time. So the first rule is if we've got two things with the same base and we're multiplying them, we add the exponents. Okay, so we have the same base, that one is A and that one is A. We're multiplying them and then we add the exponents. So, for example, if I've got 6 to the 3 times by 6 to the 4, then that's the 6 to the 3 plus 4, which is 6 to the 7. You can see it is because 6 to the 3 means 6 times 6 times 6. Then we've got another times sign, and then 6 to the 4 means 6 times 6 times 6 times 6. So obviously there's 7 of them. So you don't need to use the rule for this. You can picture this in your mind and you can work it out, and that's absolutely perfect. But you do need to understand that the rule is working. Okay, you're not going to say 6 to the 12. Next example. So this one over here is just to show you that there is no rule for when it's multiplication of different bases. So this one means 5 times 5 times 5, and then there's a times sign, and then we've got 2 times 2. So your answer is 125 times by 4, which is going to be 500, right? So you can't go and say that this is equal to 10 to the power of 5 or something ridiculous like that. That would be 10 times 10 times 10 times 10 times 10, which is going to be 10,000, which is way too big and just totally wrong. So there's no rule for blending different bases. The rule works, same base, 6, 6, now the rule works. The rule is also for multiplication. It is not for addition. So this thing here is 125 plus 25. And there are no shortcuts. You've simply got to work it out. So if you say it's equal to 5 to the 5, it definitely isn't, and it's totally wrong. It must be multiplication. So anytime you're multiplying, you should be seeing this in your mind, okay? But you can just add the exponents and you will have the right answer. Not a to the 6, a to the 5. And if you're thinking, you're going to get these things right. So you have in the past done quite a lot of these sort of examples, so hopefully you're quite comfortable with this. So distributive law as usual. I'm going to go sign first. I've got a negative times by a positive, so overall it's negative. Then number first, 6, then number next, 6 times 4, 24. Then there's 2 A's here and 6 A's there, so there's 8 of them. Same rule. 1 B there and another 4 there, so there's 5 of them. Please don't forget, if it's got no exponent, it's a 1. 1 C there, another C there, so there's 2 of them. Then a negative times a negative is a positive. So when we're multiplying here, right, a negative times a negative is a positive. 6 times 2 is 12. Then I've got a to the 6, b squared, c. And those are unlike terms, so you'd be finished and you'd stop. So the rule applies all the time, under every circumstance. There's no exceptions. Now you might see why the rule is necessary. After a while, we end up with questions like this. And that is a to the half plus a half, which is a to the 1. So that's a. So that should tell you that this is actually, that a to the half is actually the square root of a, because you're supposed to know that the square root of something times by itself is the original. If you don't, please bear it in mind with this. If I have square root of 9 times by square root of 9, then that's 3 times by 3, which equals 9, right? So this is something you really should know very well by now. But the point is, for this one, if you did know that, you could just say it's a, but if you add the exponents, you get the right answer. Here, you have no choice. You can't write out x number of 3's. What does that even mean? So you are going to now have to add your exponents. So this is 3 to the x plus 2x. So this is 3 to the 3x. And then the last example, this is 4 to the 1/4 plus the 3/4. We're going to discuss what fraction exponents mean later on. You've already had a bit of a hint from the last question, but for now it doesn't matter. And your answer is 4. Okay. Please remember, for exponents, they pretty much always want the proper answer. So they do not want you to say 3 to the 4. They want you to say 81. Okay. So unless they say leave in exponential form. That's the end of the first little video.